Welcome back, grade 9s. This is lesson 3 on chemical reactions, and we're going to discuss the energy involved in chemical change. So there are two types of energy changes during reactions. Some cases, energy is absorbed. Now, it's very important to note that when you break old bonds, those atoms need energy to separate. So energy is absorbed. When new bonds form, when the atoms come together to form the new compound, energy is released. So to break old bonds, energy is absorbed. When new bonds are formed, energy is released. The energy that is absorbed can be in the form of heat or electricity. The energy that is released can be in the form of heat or light or sound. You get endothermic reactions, and an endothermic reaction takes in more energy, absorbs more energy than what it releases when the new chemicals are formed. Where an exothermic reaction gives off or releases more energy than what is absorbed. So endothermic reaction, if there is more energy absorbed than released, and an exothermic reaction means that there is more energy released than absorbed. In an endothermic reaction, the products are less stable than the reactants, so they can decompose with greater ease, whereas with an exothermic reaction, the products are more stable than the reactants. So I'm going to describe some examples of endothermic and exothermic reactions. When hydrogen gas is mixed with oxygen gas, you just need to give it a little flame. So we give it a spark, but it's just a single spark that you give it. And what you hear is a massive explosion. So you hear sound, and just one balloon full of hydrogen and oxygen mixed and set alight will give off a lot of heat as well with light. It's a massive explosion. And what is formed? Water is formed, but it would be water in the form of vapor or a gas. So a little energy in and a lot of energy is given off. So this means that water is more stable than hydrogen and oxygen. It makes more sense. It makes a lot of sense as well because it's not easy to break up water. So this synthesis reaction, if you can remember from grade 8, where two substances join together to make one substance, is a synthesis reaction is exothermic. The second reaction I'm thinking of is the decomposition of mercury oxide. Mercury oxide, not magnesium oxide, mercury oxide. It's a solid. When you heat it, but you'll have to give it a lot of heat. We indicate that with a triangle at the arrow. It decomposes into mercury liquid and oxygen gas. Now, the moment you take the fire away, the reaction stops. So you actually need a lot of energy and the product's form gives off a little heat. There is no flame, there is no sound, there is no fire. It's just warm. So here we have something that takes in a lot of energy and gives off a little bit of energy, and this is called an endothermic reaction. And you're taking one substance and making two different substances. So this is a decomposition reaction, and it is endothermic. And the product is less stable than the reactant mercury oxide. Lastly, I want to discuss a catalyst. A catalyst is a chemical that you can add to a reaction mixture that will speed up the reaction. Now here, I wish I could demonstrate it, but hydrogen peroxide is an unstable liquid. It looks like water, but it burns your skin like fire if you put your finger into it. They use it in hair products to bleach hair. Now, hydrogen peroxide is very close to water. It's got two hydrogens joined to two oxygens in the molecule, and it decomposes spontaneously. Now, spontaneously means by itself. If you put a glass of hydrogen peroxide in the open, after a day or two, you won't have any hydrogen peroxide left because the hydrogen peroxide decomposes into water and oxygen. But it takes some time. Please note, I haven't balanced any of the equations in this. It's just to explain to you the effects of energy change. Now, if you put some iron chloride in there, the iron chloride will have FeCl3 ions in it. So the Fe3 plus ions is the catalyst. And if you add that in there, you will see the bubbles of oxygen forming very fast. It will boil over. And there are some very nice videos on this decomposition of hydrogen peroxide on YouTube that you can look up. Thank you for watching my video.